In this lecture, we will go over the CFA Level 1 reading on consumer demand. Here are the sections. We will cover consumer theory, utility theory, the opportunity set, consumer equilibrium, and then we will revisit the consumer's demand function and talk about how it is derived. Section 2, consumer theory. This section talks about how we go from consumer preferences to the demand function. Consumer choice theory relates consumers' demand curves to consumer preferences and constraints, and it considers a consumer's preferences and willingness to trade off between two goods. It also considers the budget constraints. So a simple way of looking at this is as follows. We consider what a consumer would like to do. This deals with preferences. We also consider what a customer or a consumer can do. This has to do with constraints. It's the combination of these two that will lead to what a consumer would do, and this would represent the demand function. Now we take a look at the utility theory, which is important from a testability perspective. This section has 4 subsections. We'll talk about the axioms of the theory of consumer choice, then representing consumer preference through what is called the utility function, indifference curves, which are a graphical representation of the utility function, and then a brief section on the gains that can be achieved through voluntary exchange. Before we get into the axioms of consumer choice theory, let's just define a consumption bundle or basket. This is a combination of goods and services a consumer would like to consume, and note that the same goods but different quantities means a different bundle. So if you have bundle A with 3 ounces of milk and 4 slices of bread, this is a different bundle relative to another bundle which has 4 ounces of milk and 5 slices of bread. So keep this in mind, because if you are confused about this fact, then the rest of this material will not make sense. So remember, same items but different quantities means different bundle. Now let's come to the 3 axioms, but first make sure you understand what we mean by the term axiom. An axiom is an assumption which is assumed to be true. In other words, these are the assumptions which form the basis of the consumer choice theory. The first axiom is complete preferences or completeness. This means that given a choice between bundle A and bundle B, a consumer will be very clear about whether he prefers A or prefers B or is indifferent. So saying that he likes A and B equally is also okay. What is not okay is if a consumer says that in the morning I prefer A, in the afternoon I prefer B, if it is a sunny day then I prefer this, if it is a rainy day then I prefer that. So if we get into that sort of a discussion, then this particular axiom is violated. The second axiom is transitive preferences, or also called transitivity. This says that if a consumer prefers A to B and B to C, then the consumer will prefer A to C. And the third axiom is non-satiation, where more of a given quantity is always preferred. So if a consumer has 21 bananas, then he will prefer a bundle with 22 bananas. So more is always better. Now obviously the preference of a 2 banana bundle over a 1 banana bundle, so the increased happiness of going from here to here will obviously be more than the increased preference of going from 21 bananas to 22 bananas. That is okay, but the point here is that more is always better. Now take a look at example 1 for the sort of question that you might see on the exam. Section 3.2 deals with representing the preferences of a consumer using the utility function. The utility function is a rule which translates the quantities of goods in each basket into a utility number. The unit is called utils. This is a measure of happiness and is based on an ordinal scale. Ordinal scale, if you recall from quantitative methods, means that the order matters but the difference does not matter. So if you have bundle A, which gives a utility of 10 utils, bundle B, which gives a utility of 12 utils, and bundle C, which gives a utility of, say, 14 utils, then we can say that bundle C is preferred to B, B is preferred to A. But the difference between these numbers, the difference between 14 and 12 and 2, even though this difference is the same, but that difference is meaningless. We can't say that the preference of C to B is the same as the preference of B over A. That's what order means. So C is better than B, which is better than A, and that's all we can say. The general case for the utility function is shown over here, that our utility or happiness is a function of the quantity of the different goods in a bundle. So if you have x1, x2, x3, then the utility would be a function of the quantities of those three goods. Take a specific example where we have milk and bread. Here we might say that the utility is a function of the quantity of milk and the quantity of bread, and we are defining that function as MB. Now this is one simple utility function. The utility function could also be 2MB squared, or it could be something else, but for simplicity we are saying that the utility is the product of the amount of milk in ounces times the amount of bread, say, measured in terms of slices of bread. So if we have 4 ounces of milk and 2 slices of bread, then the utility would be 8 utils. And notice that if we increase milk from 4 to 5 and let's say the bread stays the same, then the utility will go up to 10 utils. Section 3.3 deals with indifference curves, which are simply a graphical portrayal of the utility function. Indifference curves are sets of combinations or bundles of goods among which a consumer is indifferent. So continuing with our milk and bread example, and remember this represents the quantity of milk and the x-axis represents the quantity of bread. If we say that we have a bundle which consists of, let's say, 8 ounces of milk and 2 slices of bread, the utility here is 8 times 2, which is 16. So this indifference curve represents a utility or a level of happiness equal to 16 utils. Now we might have another bundle where we have, instead of 8 ounces, we have 4 ounces of milk and 4 slices of bread. So this particular bundle also has a utility of 4 times 4, which is 16 utils, and therefore these two bundles are on the same indifference curve, and that emphasizes the point over here. On a particular indifference curve, the various bundles represent the same level of happiness, and therefore a consumer is indifferent between all the bundles on a particular indifference curve. As you see over here, indifference curves slope downwards, and indifference curves also for a given consumer will not intercept, and this is because of the axiom of transitivity. Notice that the indifference curves are convex, and they are convex relative to the origin. If you look from the origin, the curves are convex. Let's understand why this is the case. Take this particular indifference curve where the utility or level of happiness is 12 utils, and let's start with bundle A, where we have 6 slices of bread and 2 ounces of milk. Say we go from bundle A to bundle B and we lose 1 slice of bread, or we give up 1 slice of bread. The change there is -1, and we get 0.4 ounces of milk. Here again our utility will be 12, so we are as happy here at B as we were at A, and we gave up 1 slice of bread for 0.4 ounces of milk. The approximate slope between A and B is equal to the change in Y, which is 0.4, divided by the change in X, which is -1. So the slope over here is equal to -0.4. Now continuing in this direction, let's say we come to bundle C. Same indifference curve, so the level of happiness is still the same. Here we have 6 ounces of milk, 2 slices of bread, so our utility is still 12. But in going from C to D, notice what happens. We have less bread, so clearly bread is more precious or more valuable. If we have 2 slices of bread, then given that we love bread, to give up that one bread we need a lot of milk. So to give up this 1 slice, again -1 on the x-axis, we need to get 6 ounces of milk. So we have to go from 6 to 12 to maintain our level of happiness, which is 12 utils. So notice what is happening. Successive reductions in the quantity of one good in the bundle, in this scenario it is the reduction in the quantity of bread, requires increasing quantities of the other good, which here is milk, to keep utility constant. And it is because of this that we have convexity. Now I gave you the slope over here, which is approximately 0.4, and between C and D the slope obviously is more in absolute terms. Notice that here the slope would be -6 because the change in Y is 6, change in X is -1, so here the slope is -6. This term, marginal rate of substitution, is the absolute value of the slope of an indifference curve at any point. So an absolute value simply means the positive value. So the marginal rate of substitution in this region is approximately 6. The marginal rate of substitution over here is approximately 0.4. Let's continue this discussion. Again, we will stay with quantity of bread and quantity of milk. Now hopefully this is obvious, but say we have these 3 indifference curves. Which curve would you prefer? In other words, where will you be happier? Given non-satiation, we will be happier on curve C than we are on curve A. So our happiness increases as we move northeast, because if you simply take this point A and then this point B, at point B we have more milk, and we have talked about the fact that more is better, so that means at point B we will be happier than point A, and we've also established that on a given indifference curve the level of happiness is the same. So clearly on curve B we will be happier relative to the happiness on curve A, and for the same reason the happiness increases as we move to curve C and so on. Now the question for you is, let's take curve B. We need to identify the point on this indifference curve where the marginal rate of substitution for bread and milk is equal to 2. And what is the interpretation of this number? Here I want to point out a few things. When we say marginal rate of substitution of bread for milk, the item that is written first is always the x-axis item. So on your exam question or in your practice questions, when you see a marginal rate of substitution, the first subscript is the x-axis, the second subscript is the y-axis. The second important point is that when we say 2, this, as I mentioned on the previous slide, is the absolute value of the slope, which means that since the slopes are all negative, the actual slope is -2. So we are looking for the point where the slope is -2. Now, given that we are talking about the slope over here, notice that the change in quantity of bread is going to be 1, and the change in quantity of milk is going to be 2. More specifically, we'll have -1 for bread and 2 for milk. So we are looking at some point on B where the slope is -2. And that is given by this point over here. Notice that if you draw a tangent over here, the slope is approximately -2. So giving up 1 unit of bread over here will mean that we would want 2 units of milk. And that is the interpretation. You as the consumer will be willing to give up 2 ounces of milk for 1 slice of bread. Or the other way of putting it is, you are willing to give up 1 slice of bread for 2 ounces of milk. Let's work through this example now. You have 10 oranges and 5 apples, and your marginal rate of substitution of apples for oranges is 3. The first thing you need to do is draw the indifference curve and show this point. Here we need to go back to what we discussed on the previous slide. So marginal rate of substitution, apples for oranges is equal to 3. Apples is written first, so this must be the x-axis. Oranges is written second, this must be the y-axis. And then the marginal rate of substitution is 3, which means that we are looking for a point where the slope is equal to -3. Let's draw the indifference curve. So we have this particular point, 10 and 5. We know that the indifference curve must go through that particular point. It's not asked, but clearly if we define the same sort of utility function that we've described before, where we say the utility is the product of the quantities, then we can say the utility is 50. Now this is just a simplification. The utility function could be different from simply the product of the two quantities. In any case, we are looking for a point where the slope is -3. In fact, we are told that the slope is -3 over here. What that means is, at this point, you are willing to give up 1 apple for 3 oranges. Another way of putting it is that you are willing to give up 3 oranges for 1 more apple. So there are 2 ways of saying the same thing. That's the interpretation. The next question is, will you be willing to give 2 oranges for 1 more apple? And the answer is clearly yes, because as we just stated, you are willing to give up 3 oranges for 1 more apple. If you are willing to do that, then obviously you'll be willing to give 2 oranges for 1 more apple. So the answer to this is yes. Now to make sure you have understood this concept, do example 2 from the curriculum. On this slide, we'll go through a simple example which will demonstrate the possible gains from voluntary exchange. We continue with milk and bread, but here notice that we have 2 indifference curves which intersect. The reason is that these are indifference curves for 2 different people. Let's say that the solid indifference curve is your indifference curve, so this is for you, and the dashed indifference curve is your friend's indifference curve. The first question I'll ask you here is, who likes bread more, you or your friend? Now think about it. Let's say that we are at this point. So this is a particular bundle which is 5 slices of bread and 5 ounces of milk. Initially, you and your friend both have this bundle. Look at your situation. You are willing to give up 1 slice of bread for 2 ounces of milk. So to go from 5 to 4, you need 2 ounces of milk. So you must go from 5 ounces of milk to 7 ounces of milk. What about your friend? For your friend, he must give up 1 slice of bread, and he is just as happy if he gets 0.5 ounces of milk. So clearly you place more value on bread, and therefore we can say that you like bread more than your friend. Now, given that you and your friend have different preferences which are depicted by different indifference curves, how can you and your friend engage in a voluntary transaction that makes both of you happier? So think about it. Here is what can be done. Say you get 1 slice of bread from your friend. Remember, you like bread more than your friend, so it makes sense that you get bread and give up 1 ounce of milk. Your bundle then becomes 6 slices of bread and 4 ounces of milk, and your friend's bundle then becomes 4 slices of bread and 6 ounces of milk. So let's look at your situation. You started out at this point, and now that you have more bread, you have moved to the right. You lose some milk, so you come down, but you will still be at a point where you are above the original utility function. So you would still be at a point where you are above the original indifference curve. Since you are at a higher indifference curve, or at a higher point, more specifically you are northeast of your original indifference curve, you are happier. What about your friend? Your friend also started out at this point, 5 and 5. Now for your friend, he has 4 slices of bread, so he has moved left, but he has more milk. Your friend likes milk more, so when he gets 6 ounces of milk, so he has more milk, he will also be at a point which is above the original indifference curve. So that makes your friend happier too. Therefore, by engaging in this voluntary transaction, both you and your friend are happier. Now do example 3 to understand this concept better. We now come to section 4, the opportunity set, consumption, production and investment choice. The focus here will be on understanding the budget constraint, and then we'll also say a little bit about the production opportunity set and investment opportunity set. The budget constraint. A budget line represents all the combinations of 2 goods that will just exhaust a consumer's income. It bounds an area representing all affordable combinations of 2 goods at current prices. I hope you recognize what's going on here. Up till now, we talked about consumer preferences, and we talked about the fact that if a consumer has more, the consumer will be happier. So the more, the better. Now we are talking about constraints, and the major constraint will come from the consumer's budget or the consumer's income. We'll continue with milk and bread. Let's say the constraint is represented by an income or a budget of 100. So this is the amount that the consumer can spend. Say the price of milk is 10 per ounce, the price of bread is 10 per slice. What does the budget line look like? Again, we will have milk on the y-axis, bread on the x-axis. If the consumer spends all 100 on milk, then he will get 10 ounces of milk. So 100 over 10 is 10. If the consumer spends all 100 on bread, then he will be able to buy 10 slices of bread. Other points on this line represent the various choices that he can make. So this point over here, for example, would be 5 and 5. A consumer might decide to spend half his money, 50, on milk, which means that he'd be able to get 5 ounces of milk, and the other half on bread, which would mean that he could get 5 slices of bread. So the point being that the consumer could buy quantities of milk and bread that are shown on this particular line. Any point outside would not be possible because the consumer does not have enough money to buy anything to the right or northeast of this particular budget line. Everything inside this budget line will be possible. If a consumer wants to buy 4 and 4, he should be able to do that. Now the question is, what will happen to the budget line if the price of bread increases to 20? Right now we have a price of 10. What will happen if the price of bread doubles? And the answer is shown right here. We will have a new budget constraint. Notice that now if the consumer spends all money on bread, then he will only be able to get 5 slices of bread. If he spends all money on milk, he'll be able to get 10 ounces of milk because in my first scenario, the price of milk has not changed. Second scenario, what if the price of milk increases to 15? And here the assumption is that the price of bread is still 10. Then we'll have this situation where we still have 10 over here, but now how much milk will he be able to buy? So if he puts all his income into milk, he will have 100, which is the total income, divided by the price of milk, which is 15. Third scenario is, what is the impact if income increases to 120? Assume that milk is still for 10 per ounce and bread is also 10 per slice. So he can buy more milk and more bread. Originally he was 10 and 10. If the income goes up, then he can buy 12 ounces of milk if milk is all he buys, or he could buy 12 slices of bread if bread is all he buys, or he could be on any point on this particular line. He could also be anywhere within that particular budget line. Now I want you to do this example. This is fairly straightforward. Here is the budget line. So I can be anywhere on this line or anywhere within the line. If I spend all my money on pomegranate juice, then this is the quantity of pomegranate juice I can buy. So 500 over 80. If I spend all my money on coconut water, then I will get 10 glasses of coconut water. The slope is simply change in y over change in x. It would be perfectly acceptable to do this the other way, where we have coconut water on the y-axis and pomegranates on the x-axis. Now do example 4 from the curriculum. Here we talk about the production opportunity set, which is an application of the budget constraint concept. Say we have a given factory where we can either produce cars or SUVs, and our constraint is such that if we only produce cars, then we can produce 3 million cars, and if we only produce SUVs, then we can produce 2 million SUVs. Or we could do something in the middle. So you could have this point over here which would represent 1.5 million cars and 1 million SUVs. This particular line is called the production opportunity frontier because this line represents the maximum that we can do. We could be either on this line or we could be within that particular line. That's why it's called a frontier. We cannot produce anything that is to the northeast of this particular frontier. The other concept you should know is that of opportunity cost. If you think about the opportunity cost of one SUV, it is 1.5 cars. In other words, if you give up one SUV, you will be able to make 1.5 more cars, or more intuitively, if you give up two SUVs, then you will be able to make 3 more cars. This particular concept will be discussed in more detail in a later reading. Investment opportunity set. This material is discussed in a lot of detail in portfolio management. Here we will simply make a few high-level points. If you think about investments, there is a trade-off between the expected return and the risk. Let's say that the risk is measured by the standard deviation of returns or the variability of returns. As an investor, you are constrained by what the market has to offer. Let's say that there is this one particular investment which is called the risk-free investment. It's typically a government security, and there the risk is zero because you know what return you will get, and that return is called the risk-free rate, generally denoted by RF. You also have the option of investing in a market portfolio, such as investing in, say, a fund based on the S&P 500 index. Let's say that is represented by this point over here. If you invest in the market portfolio, you will take a certain amount of risk, which is denoted by the standard deviation of returns of the market portfolio. So that's this risk. And you will get a higher return relative to the risk-free rate. Let's say that that return is denoted by ER. This is actually an expected return, the expected return of the diversified market portfolio. As an investor, you have a choice of being anywhere on this particular line. If you do not like risk at all, then you can put all your money in the risk-free asset. If you want to take some risk, then you might say put 50% of your money in the risk-free asset and 50% of your money in the diversified stock portfolio. That would be halfway down this particular line. Or if you want to put all your money in the diversified portfolio, then you will be at this point. What I have said so far is the material that is explicitly mentioned in section 4.3 in the curriculum. I want to add another point, because when you study portfolio management, you will also read about indifference curves and so on, but the indifference curves that you see there will look different. So I want to reconcile the difference. In this particular reading, where we are talking about two particular goods, milk and bread, for example, where you substitute between these two products, then our indifference curves have a negative slope. So notice that they are going from northwest to southeast. The reason is you give up milk for bread or you give up bread for milk. There is a substitution going on over here. In portfolio management, we talk about the trade-off between expected return and risk. When we talk about return and risk, there we need to take more risk in order to try and get a higher return. And that's why the indifference curves that you see in portfolio management slope upwards. And that is the subtle difference that I want to highlight. If you haven't studied portfolio management yet, don't worry too much about this. It will make sense once you do those readings.